So after finding this row reduction and column reduction, we can find the row scanning. We can assign the zeros by applying the row scanning and column scanning method. If you get 1 0, you can assign the 0. So except this diagonal matrix value, you can assign zeros. By using the row reduction value, we can find the column reduction values. Hello everyone, I am Shweta, Computer Science Faculty, Vidhyaashram First Grade College, Temple of Excellence, Mysuru. In my previous session, I have discussed some important problems on traveling salesman method. So today again I am explaining some important questions on traveling salesman problem. So first problem is, here you have number of rows, 5 number of rows and 5 number of columns again. Here all the diagonal matrix values are 0 because he can't travel from A to A, B to B, C to C, D to D and E to E. So all the diagonal matrix values are 0 or infinity. So what is the first step? So first step is row reduction. Row reduction or row minima. So first find out the row reduction. Dear students, in each concept I am explaining too many problems because easily you can solve all the problems. Please practice all the problems. So here first I will find out the row reduction. So in first row the least value is 10, 14 minus 10, 10 minus 10 and 24 minus 10 it is 14 and 41 minus 10 it is 31. And in second row the least value is 6. So subtract that value, it is 0, 6 minus 6 it is 0, 10 minus 6, 12 minus 6, 10 minus 6 it is 4. This is 0. And in third row the least value is 7, 0, 13 minus 7 it is 6 and 8 minus 7, 15 minus 7 is 8. And in fourth row the least value is 11, 0, 14 minus 11 is 3, 30 minus 11 is 19 and 17 minus 11 is 6. And in fifth row the least value is 6, 6 minus 6, 8 minus 6 and 12 minus 6 it is 12 and 16 minus 6 it is 10. And now I have completed the row reduction. So next is column reduction. By using this row reduction matrix values, we can find the column reduction. In first column, the least value is 0. Except this diagonal matrix values, you can consider the other value as the least value. So in first column, the least value is 0, 0. In second column, the least value is 2. So 4 minus 2, 6 minus 2, 3 minus 2, 2 minus 2. In third column, the least value is 0, 0, 4, 19 and 6. And in fourth column, the least value is 1. So 13, 5, 0 and 9. In fifth column, the least value is 4. 31 minus 4 it is 27, 0, 4 and 2. So this is your column reduction value. So after finding this row reduction and column reduction, we can find the row scanning. We can assign the zeros by applying the row scanning and column scanning method. So this is your column reduction values. So first I will find out the row scanning. We have to assign the zeros. So except this diagonal matrix values, we can assign the zeros. So if you get 1 0, put a square box around that 0 and vertical line. In second row, I have 2 zeros, just skip that row. And in third row, I have 2 0. In fourth row, I have 1 0. And in fifth row, I have 1 0. And put a vertical line. So next is column scanning. So first 3 columns are get cancelled. In fourth column, I have 1 0. Put a horizontal line. In fifth column, I have 1 0. Put a horizontal line. I have covered all the zeros by using minimum number of vertical and horizontal lines. So now you can cross verify whether it is satisfying the optimality condition or not. So I have assigned 1, 0, 2, 3, 4, 5. So number of square marked is equal to the number of rows. So how many rows are there? 5 rows are there. So it's satisfying the optimality condition. Optimality condition is satisfied. So what is the next step? You have to find the assignment. He visit A to C and C to D and D to A. So he started his journey from point A and he visit to C, C to D, D to A. Without visiting other cities, he travels from A to C, C to D and D to A. So here the condition is not satisfying. The traveling salesman problem condition is not satisfying. So we can choose the modification method. So here I will modify the assignment because B travels to and E to B. So it's not satisfying the traveling salesman problem condition. So now I will choose the modification method. I will modify the assignment. So first I will write the matrix values 2, 0, 13, 27, 0, 4, 5 and 0, 0, 4, 0 and 4, 0, 1, 19, 0, 2, 0, 0, 6, 9. I will modify the assignment. So in previous matrix representation, I have assigned this 0 as the assignment. If you assign this 0, it's not satisfying the traveling salesman problem condition. So now it is not satisfying the traveling salesman problem condition. So next, I will modify this assignment. So how to modify the assignment? So here in first row, I have assigned this 0. So again, I am assigning this 0. So below that, there is no 0 and in this row, no zeros are there. In second row, I have assigned this 0. So again, I will assign this 0 and this 0 will get cancelled. In third row, I have assigned this 0. So again, I will assign this 0. And in fourth row, I have assigned this 0 because there is no other zeros. So we have only one 0. So I have assigned this 0. If you assign this 0, so the traveling salesman condition is not satisfied. So next, I will go for the next least value. I am modifying the assignment here. So here, I will choose the next least value. So 1 is the least value. I will assign this 1 as an assignment. So I can cancel this 0. And in the last row, if you assign this 0, so it is not satisfying the condition. So the next least value is again 0. I will assign this 0. Now you can cross verify whether it is satisfying the traveling salesman condition or not. He visit from A to C and C to D and D to B and B to E and E to A. Now it's satisfying the traveling salesman problem condition because he started his journey from point A and again he returns back to the same position and he visits each and every city exactly once. So now it is satisfying the condition. Now I can find out the total cost. And the total cost is A to C. So A to C means it is 10 plus C to D. C to D is 8 and D to B. D to B means it is 14 and B to E. B to E is 10 and again E to A. E to A is 6. So total kilometer is 10 plus 8 is 18. 18 plus 14, 32. 32 plus 10, 42. 42 plus 6 is 48 kilometers. So this is one example for traveling salesman method. The next problem is, so here you have 5 number of rows and 5 number of columns, and all the diagonal matrix values are 0. By using this matrix representation values, we can find the row reduction and column reduction. So, I hope you know about row reduction and column reduction, right? In every row, you have to consider the least value. So, in first row, the least value is 2 and subtract with the other value. And in second row, the least value is 5. And in third row, least value is 11. And in fourth row, the least value is 11. In fifth row, the least value is 2. Subtract this and find the row reduction value. And by using the row reduction value, we can find the column reduction values. So, in first column also you have to consider the least value and subtract with the other value. And in second column, consider the least value, third column, fourth column and fifth column. So, this is your column reduction value. So, now I will assign the zeros. In first row, I have 1 0, put a square box and vertical line. And in second row, 1 0 and vertical line. In third row also 1 0, vertical line. And in fourth row, we have 1 0, assign the 0. And in fifth row, I have 1 0, assign this 0. And the next step, we have to check whether it is satisfying the optimality condition or not. In row scanning only, I have covered all the zeros. So, how many number of square I have marked? 1, 2, 3, 4, 5. So, number of square marked is equal to number of rows. So, 5 equals 5. So, it's satisfying the optimality condition. If it is satisfying the optimality condition, I can move further. So, now you can find the assignment. So, assignment is A to E. He visit A to E, then E to A. So, A to E, E to A. So, without visiting other cities, he directly visited from A to E, E to A. So, it is not satisfying the traveling salesman condition. So, we have to modify the assignment. So, here A to E, E to A, then B to C, then C to D, then D to B. Now, you can modify the assignment. First, I will write the matrix 12, 0, 18 and 0, 12, 9, 0 and 9, 24, 0, 3 and 3, 0, 6, 0, 21. If you use this assignment, the condition is not satisfied. So, now I will modify the assignment. Instead of this 0 as an assignment, I will take the least value as an assignment. So, next least value is 3. I will assign this as an assignment. So, I can cancel this 0. And in second row, I will assign the same 0. And in third row, again I will assign the same 0. In fourth row, if you use this as an assignment, so it is not satisfying now. So, I will modify it again. So, now I can't assign this 0 because over that already I have assigned one more assignment. So, now I will select the next least value. So, 0 is the least value. The next least value is 3. But I can't assign this 3. Already we have one more assignment here. So, now I will assign this 3 and I can cancel this 0. And last row, I will assign this 0 as an assignment. So, now you can cross verify whether it is satisfying the traveling salesman problem condition or not. A to B and B to C and C to D, D to E and E to A. So, now it is satisfying the traveling salesman problem condition. So, please find out the total cost here. So, this is about your traveling salesman problem. So, I am explaining so many problems. Please practice all the problems. If you missed my classes, please follow the link below and please practice all the problems. So, in my next session, I will come with a new problems. Thank you.